If you clicked on this video, you probably know what embeddings are. Embeddings are vector representations of data, and those with close semantic meanings are placed close to each other. So for example, let's say if I have a bunch of embeddings of movies right here, and I take the embedding of Avengers Endgame or something, I can perform a vector search against this group of embeddings and get content like, any of the other Avengers movies, or maybe Captain America or Iron Man movies, right? Something that's semantically similar to Avengers Endgame that I'm holding, and I'm totally not gonna get Pokemon, for example, out of nowhere, because that's obviously semantically very different from what I have here. So that's simple, right? I have one movie and I want to find other movies that are similar to this. But what if I want to suggest content based on my personal behaviors? What if I like heroes, but I also like Pokemon, or this or that, or I don't like certain things, or here are my view history, right? As a person, I have different behaviors. What if I want to create a sophisticated system that can suggest relevant content based on these all, human interactions? Turns out there are ways to surface these personalized content using embeddings. We'll be looking at adding, subtracting, taking averages, doing different kinds of modifications to embeddings to surface personalized content for your users. Let's dive in. So just as a quick reminder, embeddings are just vector representations of data, whatever this data could be. In our example today, I'm going to mainly talk about movies, but it can be really anything, your social media content, e-commerce product, anything can be converted to embeddings. Now, most of the time, embeddings have way more dimensions than just 2 dimensions, but it's pretty much impossible to do anything beyond 2 dimensions, maybe 3 if I really tried, but nothing beyond that, obviously. So I'm gonna explain everything in this two-dimensional plane. So let's say we have 3 vectors right here, right? These 2 vectors up here represent something similar to each other. Maybe they're Iron Man and Captain America movie or something. Whereas this lower left vector represents something that is not at all similar to any of those movies. I don't know if Pokemon's polar opposite of those movies. I don't know, Hello Kitty movie or something. Whatever it is, something no fighting, childish, or something like that, right? That's the point. Something similar are kind of grouped together, clustered together, whereas something semantically different, totally different, are somewhere else. That's what embeddings are. And the way you can surface these personalized content is by creating a personal interest vector. So let's say this red vector represents my personal interest. If I am interested in these hero types of movies like Avengers, Iron Man, that sort of stuff, if I can have my personal interest vector in my database that is somewhere over here, then I can just perform a vector query using this personal interest vector, and hopefully that gets these 2 vectors back from the database. Whereas if I'm interested in something more, peaceful and kind or something like that, maybe my personal interest vector is like over here, and that'll get me this vector or whatever other vectors may be around that, right? So if I can place this personal interest vector accurately at where my personal interests are towards, then I can just perform a simple vector search using that personal interest vector. Right, more or less, I will be talking about more advanced techniques later on, but this is the core idea. So you have some kind of vector that is not associated to any of the movies, but is associated to you within this vector space of movies. That's how personal recommendation basically works using vectors. So then the question is, how do you find the proper interest vector for each users? Well, let's see, there are multiple techniques, but one simple technique is to take average of a few videos that this person has watched, or a few content that this person has consumed. So let's say the user has consumed these 3 content over here, right? Then we can take the average of these three vectors, basically 1, 2, 3, and take the average. So that's one way to do it. You could look at, I don't know, 10 last viewed movies or something and maybe take the average or something. That is one way, but there's a smarter way of doing it, and it's called exponential moving average. So what it does is it favors the more recently viewed vector. So let's say our current personal interest vector is over here, right here, something like that, right? And let's say we just consumed this vector right here. Then every single time a user consumes a content, we modify the personal interest vector based on the new content that this person watched. How do we do it? We take the personal interest vector, right, that we have already, and we also take the newly viewed contents vector, embedding. We give it some kind of multiplier, something like 0.1, 0.3, something like that. This number is kind of arbitrary. You have to kind of play around to get it right. But let's say it's 0.3. Then we multiply this vector by 0.3, so shrink it like that, something like that, right? And then we take the personal vector and add it, and we also multiply it by whatever's remaining, so 0.7 in that case, something like this. And this new vector that is surfaced right here becomes this person's new interest vector. And as you watch more content, if the user happens to watch this content on the lower left, then we use something similar as well. We take this vector, multiply it by 0.3. We take this personal interest vector, add it, right? And then we get a new vector that is pointing up, kind of like this. Now, when I'm explaining this in two-dimensional plane, it kind of sounds ridiculous. Even like calculating averages of vectors seems like it doesn't have any semantically meaning. Like, what if you have one vector pointing this way and the other vector pointing that way, and you add them to take the average and you get 0? You know, what if something like that happens? It seems very much possible when you're working with two-dimensional planes, especially when all the vectors are normalized. But this is where it gets hard to imagine because you can only think in up to three-dimensional spaces. But the more higher dimension you go, it's less likely that two vectors will strongly cancel each other. It becomes extremely unlikely that two vectors are in the polar opposite. Again, it really depends on various embeddings models and whatnot, but typically we are working with at least 200, 300 dimensions, probably way more. The particular example that I have prepared today is using 1,500 dimensions, so we really don't need to worry about these type of stuff. In fact, these similar concepts are often used in gigantic websites like YouTube or Netflix, where recommending personalized content is crucial. So yeah, let's actually see it in action. So I created this simple YouTube clone app and loaded a bunch of movie data from the MovieDB API. And I've also generated embeddings for all of them. So I have this videos table with a bunch of embeddings data. So each movie has an embedding, and I have a total of 1,800 movies to work with. If we go to the profiles table, I have one user, that's me. For this demonstration purpose, I don't really need anybody else. This user has an interest vector column. So this interest vector is the interest vector that I was talking about, the interest vector that gets modified over time. So to keep it simple, when the user first lands on this website and whatever the user views first, that will be set as the initial interest vector of the user. This problem is often called cold start problem, how to navigate the newly fresh user to the relevant content. It's kind of a tough problem to deal with, but to keep things simple, a fresh user lands on this page, they're gonna see a bunch of movies. Whatever they click on is going to be their initial interest vector, right? Now, my homepage is already personalized using that interest vector. I guess I was interested in Avengers type of stuff. Now, when I click to view these videos, which is not going to play because I don't have the actual data of the video itself, but let's pretend that we're viewing the video or movie. In the background, it's performing that exponential moving average, basically shifting my interest vector a little bit towards whatever the new content that I'm viewing. So I guess obviously if I'm viewing any of the top content, the interest vector doesn't shift too much. But if I view something very different, in fact, I can perform a search. Something like Toy Story maybe, right? Peaceful, not so much fighting. Okay, let's view Toy Story. And now that I view Toy Story, we can go back to the homepage. Now my homepage is kind of shuffled up. I have Toy Story 2 and Toy Story 3 up here. I still have Avengers, more Avengers content or Iron Man content over here. But then as we scroll down, I have some Lego content, The Incredibles. So I didn't explain this earlier, but this home screen displays the most relevant to least relevant, and it's showing the top 50 content that is close to the personalization vector. So all it's doing is it's performing a simple vector search against the database using my personalization vector. So, just by watching a single Toy Story video, my personalization vector has already shifted. If I click on Lilo and Stitch, I think it's gonna shift even more. Right, so a bunch of Toy Story stuff, some Bolt, Big Hero 6. We still see Avengers, which is good, right? Just because we watched 2 videos that are totally unrelated to Avengers, that doesn't mean I'm no longer interested in Avengers, right? So there's a few parameters that we can play with here. Let's see the code that's actually doing this. So in this particular example, I'm doing everything in C code, but the particular language is not too important. It's more of this concept of incrementally updating your interest vector to surface personalized content is the important idea here. So up here we have this function called update interest vector on video view. I think that's pretty self-explanatory. But we have a few parameters that we can play with. The main one that we will play with is this 0.3 alpha value. This is a value that was multiplying to the new videos. If you remember the explanation, you watch a new movie and then you multiply that by 0.3 or 0.1 or something, and then you keep your interest vector, multiply that by whatever is remain. Basically, this value is how fast your interest shifts when you watch new content. If you remember it, when I watched a single Toy Story video, it kind of shifted pretty drastically, I would say. So in that case, I might want to kind of dial down this value a little bit. Or if there's like a like feature and I can explicitly say I like this video, then we can shift the interest vector even more towards that particular video, right? There's multiple ways of playing with this particular value, but the idea is over time as you watch more content, your interests is kind of aligned, self-corrected with all the content that you watch. So all we're doing is nothing too complicated. We're retrieving the interest vector of the user, and then we're doing some vector math to calculate the new interest vector. At the end, normalize the vector just because it's easier on the machines when you do vector maths. So that is in effect, and I can play with it more. Maybe if I watch something like, I don't know if there's Pokemon movies here. Okay, there's no Pokemon movies, but maybe Sonic the Hedgehog, or maybe this cute dog movie. Yeah, let's watch this cute dog movie, and then maybe more dogs. I can find more dog movies from this sidebar, because this sidebar is actually just performing simple vector search based on this main movie. And go back to the homepage maybe. Now my homepage is kind of filled with dog movies, right? So here's where you might want to adjust, maybe 0.3 is a little too much. Maybe we can dial it down to 0.1. And the right value for your particular use case is widely depends on your particular use case or the embedding model that you might be working on, right? Different models have different distributions within the vector space. So things like that could play a role determining what's right for you, but it's kind of fun to play with. Now let me talk about another technique that you can use to modify your interest vector, and that is to subtract vectors. And you can use this when you want to, for example, remove certain type of content from your recommendations to your users. In this particular example, I have a bunch of dog movies in my home screen, which is fair because I watch a bunch of dog movies, right? But let's say I kind of want to get rid of these dog movies now. Now, what I can do is, what I have here is I have this not interested button. Upon pressing this, I shift my interest vector to subtract the target movie away in a way. So let's say we have three vectors like this. The red one is my interest vector. And let's say I don't like this particular content on the lower right. Well, we can, upon me pressing the I don't like this button, I have it configured to do this. First, basically it subtracts the target vector from the interest vector, but I don't straight up subtract it. Subtracting it straight up shifts the interest a bit too much typically. So what people do typically is that they have a multiplier that they multiply to this target vector to make it smaller and then subtract the vector. So the final interest vector will look something like this. And then after normalizing, it'll be something like that. So this new interest vector has less component, less relevance to this target vector. Obviously, it doesn't really make sense when it's in two-dimensional space. It doesn't look like it's gonna work, but it'll work in an actual example with more dimensions. So let's dive into the actual example. So again, here's the not interested in button, and upon pressing this, this dislike video postgres function is being called. And all it does is what I explained right there. So basically it takes the target vector, multiplies it by whatever the subtraction factor is, in this case 0.5, and subtract that from the interest vector, recalculates the new interest vector, normalizes it, and inserts it back to the user's profile. So let's do it. Let's see if we can get rid of all these dog videos. So I've disliked one movie. Let's refresh it. What we get? Okay, I'm seeing less dogs, but maybe more dogs up here. So let's dislike that as well. Let's see what we get. Okay, definitely less dogs for sure. I don't see any dogs at all in any of my timeline. So see, it's kind of conceptual. It's kind of, there's no like clear way of, okay, this worked, this didn't work. So I'm gonna say in this particular example it worked, and obviously you can play it a little with this subtraction factor, whether 0.5 is too big or too small. Again, it depends on your embedding model or your particular use case, but I'm gonna say that was a success. Now, the last technique that I want to talk to you about is called temporal analysis, and it has something to do with analyzing historical data. So let me show you an example. Let's say these three red ones are all my interest vector. The one at the below is from 2 weeks ago, one in the middle is last week, and then the one at the top is my interest vector today. By inspecting the historical trend of these interest vector, we can predict where my interest will be in the future. I mean, it's a pretty simple example, but somewhere like that there, right? Somewhere around there seems like where my new interest will be. So we can see that, this interest is moving upwards with this much jump every single week. So this is a simplified version of what this temporal analysis is, but that's what it is in a nutshell. You look at historical data of how people's interests are shifting and take that data to predict the future. Now, you can perform this at the personal level or as an aggregate level. If you look at it at the personal level, you can predict what this particular person wants to see next week or something like that. Whereas you can take the average of a group of people and see where this group of people are headed towards. You can maybe take a look at what younger people are looking at, or what businessmen are looking at, or people in tech are looking at. Right? You can group people in different ways, see what they're looking at, and predict what they want to be looking at in the future, whatever that means, in a month or in a week, tomorrow, 15 minutes from now, crazy times. So that's what temporal analysis is, and I have a very simple example of showcasing this particular feature. So on actual temporal analysis, you probably want to look at multiple weeks, months, whatever interval makes sense for your platform. But something like, you take the average of 3 weeks ago, 2 weeks ago, a week ago, today, and then you predict a week from now. And then using that a week from now vector, you can maybe already show the content that the user might want to watch in the week, or you can do whatever you want to with it. Now, to emulate that, I've kind of created this temporal predictions mode within this web app. So upon enabling this, it looks at my historical view history. So the reason why you see a bunch of dogs is because now we've kind of taken away that subtracting vector kind of thing, but it's only looking at my view history. It's looking at the past 10 view history, and it's taking a look at the first 5, the second 5, take average of these two, and then predict what comes next. Obviously, it seems like a lot of dogs. Probably because I watched a lot of dog videos towards the end, but we can dynamically change this as well. So if let's say, so right now it looks like I'm watching a bunch of dog movies, right? And let's say if I start watching a bunch of, what are some good movies? Maybe sports movies, football. Let's see what takes us. Dog from sports. What comes next? I think it's interesting. Not a lot of football movies, huh? Interesting. Okay, The Blind Side. Sure, not sure if Pursuit of Happiness is... Why not? Okay, I'm just gonna go with that. Pursuit of Happiness. Maybe I should have stuck with sports. Okay, Moneyball. What else is sports? Really, not a lot of sports movies. I don't know. Is there like Coach Carter or something? Are these even sports? Space Jam, sure. That's sports. Interesting. But what else is there? Blindside, Moneyball. Really? Baseball? No baseball movies? That is interesting. Okay, I'm gonna click on this one that looks like a football movie. The Longest Yard. That looks like a football... That sounds like a football movie, right? Okay, I'm gonna call that good enough. And let's see. So we had a bunch of dog movies, and then now we watched... I kind of messed it up, but we watched a bunch of football movies. And now that's taking us towards Stormcatcher, The Day Earth Blow, Con Air, Shot Caller, Chicken Little. Honestly, it looks like it's kind of all over the place. A lot of kung fu movies down there, a lot of fighting movies. Yeah, I'm kind of struggling to find a common pattern within the list of movies that I'm showing right now. Maybe we can start over. Let's start over. So let me delete the watch history. Let's kind of carefully choose the 10 movies to watch. So what can we watch? So let's watch Avengers. Avengers movie. That's always easy. So there's the Avengers Infinity War, Endgame, 1, 2, 3. Then Iron Man, Spider-Man. Was that 3 or 4? No, was that Oh, okay, that was 6. I am going to delete one of them. Alright, we can watch 5 more movies. What kind of movies? Let's just watch a bunch of happy Disney movies. I'm just gonna search Disney. Okay, Tinkerbell, The Lion King. Sure. Tinkerbell. 1, 2. Frozen. 3. Frozen 2, yeah. 4. Cinderella 2. Let's see. Moana 2, yeah. 5. Okay, so we watched 5 Avengers movie and then 5 Disney movies. And this is the result of the temporal analysis. It looks like it's understanding that I'm going heavily into this fantasy world, a bunch of princesses, overall happy themed movies. So if we look at the code behind the scenes, the way it's working is there's a few different moving parts here that we can tweak, but here I have this generate temporal prediction of vector function. So essentially this function produces a vector at the end, and I take that resulting vector and perform a typical vector search against the entire database. Simple. Now, what it's doing is it queries the 10 most recent history first. So that's happening right here. And then as you query them, it gets split into the first half and the second half, right? The splitting is happening right here. And then once we get the 5 vectors on each, we calculate the average, and then we calculate the vector that's going from the old one to the new one. That's happening right here. And then essentially we take the old one. At that point, we essentially take the new one and then add the momentum vector, if you will, to the new vector. And we come up with a new vector, right? And then at the end, we just normalize that and use that to perform vector search. So this is a quick and dirty version of this temporal analysis. The more vector you have, the better, right? The more history you have. So maybe we can look at 3 or 4 different data points across history, whereas in this particular quick and dirty example, add 2 data points. But even then, you can kind of see that there is a trend that the system is automatically understanding through my watch history. So those are just a few examples of how you can level up your personalization within your app. And if you do some research, there's so many other techniques. If you find your favorite, please let me know in the comments below. Otherwise, I'll see you around with another Supabase video.